Hi FOM 12 students, this is lesson 6.2 of our polynomials chapter. 6.2 is called characteristics of the equations of polynomial functions. And I can call mine answer key. And it says the goal of this lesson is to make connections between the coefficients and constant in the equation of a function and the characteristics of the graph of the function. So some key terms are the constant term, the leading coefficient, and the degree. And so as an example, let's say we have a polynomial function like this. 2x cubed plus 6x squared plus 7x minus 3. And we put them in order like that, from the highest power of x to the lowest power of x. And when you do that, guys, the excuse me, the leading coefficient is the number in front of the highest power of x. Okay. And the degree of the function is equal to the highest power of x. So the degree is the highest power of x. In this case, it's 3. And we also have this key term called the constant term. The constant term is the term that doesn't have an x attached to it. It remains constant at -3. So this is the constant term. And the thing about the constant term is it always ends up being the y-intercept of the graph. Okay, that's true for polynomial functions. Okay, that the constant term ends up being the y-intercept of the graph. Okay, so let's recall some of the properties of some specific polynomial functions. First of all, we started with linear functions. And there's kind of a special straight line linear function that is of degree 0. And that's when you have a horizontal straight line like this. Like, for example, the one that I graphed there is f of x equals 4, y equals 4 all the time. And this type of function is called a constant function. And it has a slope of 0. And the ones that I'm going to do over here, these are sort of the more normal linear functions. They will be of degree 1, which means they will have one possible x-intercept. Okay, and these are functions like this. F of x equals 3x plus 1. This one has a positive slope. And if we graph it, the y-intercept you can see is positive 1. The slope is 3 over 1, so you go up 3, 1 to the right. And up 3, 1 to the right. It goes off like that. Back the other way is down 3, 1 left. Down 3, 1 left, down 3, 1 left. Okay, remember how the quadrants go 1, 2, 3, and 4? We can see that as we move from left to right, this graph moves from quadrant 3 to quadrant 1. Okay, so that's a positively sloped linear function. It is degree 1 because the highest power of x is x to the 1. And let's do another one like this. F of x equals negative 2/3 x minus 2. So that has a y-intercept of negative 2, a slope of negative 2 over 3. So down 2, 3 to the right, down 2, 3 to the right, or up 2 and 3 left. Okay, so you can see that this linear function has a negative slope. And if we do the quadrant thing, this moves from quad 2 to quadrant 4. Okay, and then we talked about quadratic functions, and quadratic functions either look like this, upward parabola, or down like that. And these are of degree 2, meaning the highest power of x is x to the 2. And that also means that there are 2 possible x-intercepts. Okay, so we could have one like this. And for example, this could be something like this. X squared minus 2x minus 3. Okay, so when it's facing up, the x squared has to be positive. So it's a positive x squared, and when it's facing down, it has to be a negative in front of the x squared. And actually, that's what I was going to say in the second bullet here. You have to have a positive leading coefficient. And that positive leading coefficient right there is 1, secret 1. And this moves from quadrant 2 to 1 as you move from left to right. Okay, so another type would be like this and facing down. F of x equals negative 1x squared plus 3x plus 4. Oh, and I should have highlighted this as the y-intercept. This example has a negative leading coefficient. That positive 4 is the y-intercept. Okay, you can see that that's right here, right? The y-intercept. I'm just going to erase that. Okay, and this one moves from quad 3 to quad 4. All right, cubic functions are of degree 3 because it's x cubed. Cubic functions, degree 3, and that means that there are 3 possible x-intercepts. And so, for example, we could have f of x is equal to 2x cubed plus 6x squared minus 5x plus 2. This is going to be the y-intercept. And we did have some x-intercepts like this. Okay, and since the leading coefficient is positive, the graph kind of moves up and to the right like that. So when you have a positive leading coefficient, this is how a cubic graph looks in general. There's the positive leading coefficient. And it moves from quadrant 3 to 1. Okay, and so here's what happens if we have a negative leading coefficient. Let's say we have negative x cubed minus 2x squared plus x minus 5. There's the y-intercept. We have a negative leading coefficient, which is right there. And when that happens, the graph goes like this. Looks like we have something here. Okay, see how in general the graph moves down as you go to the right. And we can say moves from quadrant 2 to quadrant 4. Okay, let's try an example. Determine the following characteristics of each function using its equation. Number of possible x-intercepts, the y-intercept, the end behavior, the domain and range. Okay. The number of possible x-intercepts is equal to the highest power of x. That's x to the 1. So there is one possible x-intercept. The y-intercept is this. So with that second bullet, we can say the y-intercept is negative 5. So the y-intercept is down here at negative 5. The slope is positive, which means, and it's a linear, which means it looks like this. Okay, so basically, guys, when it's x to the 1, it's either going to be a positively sloped line or negative. So positive or negative. When it's x to the 2, this is positive leading coefficient and negative leading coefficient. And x to the 3, oops, let's fix that. X to the 3, this is a positive leading coefficient, and this shape is from a negative leading coefficient. Okay, so that's how I knew how the graph looked, roughly. And so then we can do its end behavior. We can see this moves from 3 to 1. The domain of any polynomial is all real, because the graph goes from left to right forever, covering the whole x-axis. This one happens to go up forever and down forever, so it covers the whole y-axis. So the range is all real as well. Domain is x, range is y. And the number of possible turning points, we have 0 turning points for a straight line. Okay, let's try letter B here. So just from the equation, the number of possible x-intercepts is the highest power of x. So we can say 2 possible x-intercepts. The next bullet is the y-intercept, which is the constant term. So the y-intercept is 8. And the end behavior, we need a graph for that. Y-intercept is up at 8. We've got a negative quadratic, so a negative facing parabola like that. Okay, so the end behavior goes from 3 to 4. And then over here we're supposed to do the domain is all real. The range, these kinds of graphs either have a high point or a low point. It has a highest point up here. So the range we would say is y is less than or equal to 8. You could put greater than negative infinity if you want, because negative infinity is like that. That's how high and low the graph goes. And number of possible turning points, you can see it comes down, or sorry, it comes up to the top of the hill and then goes back down, so there's 1 turning point. And letter C is a cubic. Highest power of x is x to the 3. So the number of possible x-intercepts is 3 possible x-intercepts. The y-intercept is this guy, the constant term, negative 10. The end behavior, we have to have a y-intercept of negative 10, and the leading coefficient is positive, which means we ultimately have to head up and to the right with our cubic. So that's going from quadrant 3 to quadrant 1. The domain of any polynomial is all real. You can see the whole x-axis is covered. The graph goes up and forever and down forever, so the whole y-axis is covered. All real. And the number of possible turning points, we've got a turning point here, it goes up to the top of the hill and then switches direction, and then down to this valley and then switches direction, so there's 2 turning points. And that is example 1. Example 2 says match each graph with the correct polynomial function, justify your reasoning, and I was supposed to put a photocopy from the text there. We don't have it, so please check out page 388 for that. And let's see example 3. Example 3 says sketch the graph of a possible polynomial function for each set of characteristics below. What can you conclude about the equation of the function with these characteristics? Okay, so it has a range where there is a lowest point, and the only time we saw that was with a quadratic. Right, because linear goes like this, up forever and down forever. Quadratics are the ones that have a high or low point, and cubics go up and down forever. So it must be a quadratic. Y has to be greater than or equal to -2, so that's the lowest point, and we have to have a y-intercept of 4. So it must be something like this. Okay, or it could have been on the other side of the y-axis. Okay, so what can we conclude about the equation? It is a quadratic function. So that means it has degree 2. So it's x to the 2. Okay, so you know how these ones are x to the 1, these are x to the 2, and these are x to the 3. It has a positive leading coefficient because it's facing up. Positive leading coefficient. And the y-intercept is the constant term, so the constant term is 4. All right, letter B, the range is all real. Turning points, one in quad 3 and another in quad 1. Well, with our linear functions, there were no turning points. X to the 2 has only one turning point, right? Right here or right here. So it must be some sort of x to the 3 graph with a turning point here and a turning point here. The range is all real. We've got a turning point in quadrant 3 and another in quadrant 1. So I think it's going to have to come down like this and do a turning point, and then into quadrant 1 and do a turning point like that. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. Okay, so what can we conclude about the equation of a graph like this? It is a cubic function, which means it is of degree 3, and it has a negative leading coefficient. Remember, the ones that ultimately move down as we head to the right have a negative leading coefficient. All right, so there you go, everybody. The homework is from the textbook. It looks like this. And there you go. I think this might be the last formal lesson that I send you, everyone. And so if you're graduating this year, congratulations on your grad. And by all means, come back to PMSS anytime for a visit. It would be great to see you. And I wish you all the best in the future. Talk to you soon, everybody.